Good. Right. Yes, so my name's Liz Rice. Je parle un peu français. Après, je peux essayer de discuter en français, but I'm going to do my presentation in English because we don't want to be here all day. So I work with Aqua Security. We help enterprises secure their container deployments. And the theme of today is orchestration. So the question is, does orchestration help with security, or does it create additional threats? So how many of you are currently using containers? Lots of people. Keep your hand up if you're using containers under an orchestrator in production. Okay, quite a few of you. Good. All right. So if we think about cloud-native deployments, we might think about running containers under orchestration, and maybe those containers are being used to encapsulate microservices. So we might have applications that are broken down into microservices. So what does that look like? It looks like lots of hosts with lots of containers. So it's not unusual to have perhaps hundreds of microservices. And each of those microservices has several instances. So you could have thousands of containers. And the orchestrator is responsible for putting those containers on different hosts. So as a human being, you don't really know where any given container is going to end up. And those containers churn pretty regularly. Datadog did a survey that showed that the average, or wasn't a survey actually, it was analysis of data from their observations, that showed that the average container life is only 2.5 days, which compares to an average life for a virtual machine of more like 23 days. So we have thousands of containers running somewhere on this set of hosts, and they're changing all the time. They're changing every 2.5 days. So if you're a security professional and you look at this picture, you're probably kind of concerned. And in fact, a very large majority in a survey agreed that they were concerned about security when deploying containers. And it's not really that surprising when you see that sort of big picture of lots of containers. So let's think about how we did security in traditional environments. This is like the most simple diagram I could come up with for the process. But essentially, we'd have developers who would write software. We'd have operation people who would provision the servers for that software to run on. And then maybe once, twice, 3 times a year, we would deploy that software into production. It doesn't happen very often, and it's a big deal. And then we have the problem of security patching. Security researchers are finding vulnerabilities in existing code all the time. And whenever they find a new vulnerability and then create a fix for that vulnerability, we'd have to update these servers with those latest patches to keep them as secure as possible and stop people being able to attack via those new known vulnerabilities. So if we think about having like a lot of containers, how on earth can we conceivably patch? How can we keep all of those containers up to date with all those latest security patches? Seems like a nightmare, seems like a headache for security people to have to stay on top of all these containers. And the answer, of course, is that you don't. You don't patch containers. You don't patch the running images or the running containers in your deployment. Instead, we have automation, we have CI/CD pipelines. So in our kind of cloud-native world with containers and microservices and orchestration, we're typically using some kind of continuous integration, and maybe even continuous deployment to automate this process where we build our software, we put it into containers, we build container images, and then we deploy those images through the orchestrator. And every time we want to add a security patch, we need to come back to the sort of left-hand side of this pipeline, and we always go in that direction. If we want to apply a new security patch, we build a new container image and then we deploy it. So if we look at our running orchestrated system, and somewhere in there we can identify there's a tiny orange, there's one container that's got a vulnerability. We have to identify which one has the vulnerability, and then we have to rebuild it and replace it with a patched version. So we're using our CI/CD pipeline to automatically build the new version and redeploy it. So how do we identify which of these containers have vulnerabilities? Again, we've got hundreds of these images, maybe thousands, maybe tens of thousands of container images. It's really easy to build an image because we've automated it with CI/CD. So we also need to automate the process of looking for vulnerabilities in those images. And we can use vulnerability scanners to do that. You can use commercial products like Aqua. There are other commercial products available. There are also free and open source products available. And those are going to look at your container images, look at the packages and the files inside those container images, and compare them with a database of known vulnerabilities and let you know if your image has any of those problems baked in. And we potentially want to be running that scan at the point where we build the image, because there's no point kind of shipping something that has a known vulnerability in it, or at least a high severity vulnerability. We might want to scan before we actually deploy to make sure that we haven't discovered a new vulnerability since we built the image. And we probably want to be scanning the container images that are currently running in our system so that we can spot that container that we need to replace and rebuild when a new vulnerability gets discovered. But we can also use this kind of automated process to help us with other kind of policy requirements around those container images. So we might want to check that the developer used, the from line in your Docker file. We might want to make sure that that is using a approved base image that your organization or the security team in your organization is happy with. It's really common to have an approved base image for each different language. You might, here is the version, here is the base image you should use if you're writing in Java. Here is the base image you should use if you're writing in Python. And we can use scanning and image policies to make sure that we're actually using those base images and that we're not some developer hasn't decided to go off-piste and use a rogue base image. We can also be checking for things like including sensitive data like passwords or API credentials in those images. You don't want to have those baked into your container images, and you can use scanning to check that. You might well have policies around what level of vulnerabilities you're prepared to accept. When you run a vulnerability scanner, it's very, very, very common to find that there are low severity vulnerabilities reported that you may actually think, it's not worth the trouble of trying to fix those. We'll just accept those. And that decision on which vulnerabilities you're prepared to accept, what level of severity you're prepared to accept, whether there are particular vulnerabilities that you kind of have to live with because your application requires that particular version of a library. All of those things can be built into policies so that you make sure you don't deploy an image that doesn't meet your policies. So all of these checks can be built into your CI/CD pipeline. And you can essentially push back to develop. How many of you are developers in the room? How many consider yourself developers? Right, so in a containerized world, security becomes part of your responsibility as well. If you're responsible for a container image that doesn't meet these policies, or that includes some kind of vulnerable library, you probably need to change your software, or you need to change your Docker file, or you need to make some changes so that you can get your container all the way through that CI/CD pipeline, passing the policies. Okay, so we can use vulnerability scanners and image policies to make sure that we're only deploying container images that we think are pretty secure. But what about the servers that those images are going to be deployed onto? Orchestration is going to run those containers somewhere on our cluster. What can we do to protect our hosts? And there are a few things that really come out of the fact that we are using containers, the fact that we're using orchestration, that can actually help us with security of the hosts. And the first is the software that we're actually running on the hosts themselves. All you need from your hosts is the ability to run containers. You don't need any other software other than what you need to run. Maybe monitor, maybe security, but essentially it's not running any application code directly. And there are operating systems designed to run containers, things like Container OS, Project Atomic, Rancher OS, the work that Docker have done with Linux Kit to build smaller operating systems. The less software there is running on your host, the less there is to attack, the less likelihood that you're running something with a vulnerability. So minimizing your host is a good thing, and it's something you can do because you're running containers. Automation is your friend, again, with hosts. So there are tests that you can run on your host to make sure that they're configured correctly. For example, a project that I'm involved in called KubeBench, which checks that the hosts are all in compliance with kind of security best practices, configuration best practices that have been written by an organization called the Center for Internet Security. So it's a big set of tests. Be a nightmare to run it manually, but you can use tooling like KubeBench to run it automatically and make sure that your servers are configured correctly. Recycling your hosts. So you know how we talked about destroying a container and replacing it with a new one? It's actually a good practice to do something similar, to bring down your nodes, to bring down your hosts and replace them with new ones. Your server configuration should really be coming from code. Maybe you're using Terraform or something like that to configure your hosts. So you should be able to recreate exactly the same host pretty easily because it should be automated. And if you can do that, you can just, you've got a big cluster of machines and you can tear down a host, rebuild a new one. And the advantage of that is, just suppose there were an attacker, somebody has got into that host. It takes them a finite amount of time to go from getting onto your host to actually doing something like extracting your private data. If you manage to recycle that host while they were in the middle of that attack, before they'd done anything useful, well, you just basically stopped the attack. You've taken away what they changed. The attacker who was on your host is no longer on your host because you can automatically recreate that host. And you're constantly bringing your servers back to the kind of known state that you configured them with. The other advantage of doing this kind of node recycling on a regular basis is that you know that when something goes wrong, if you have a host that just fails, you know that your processes for replacing it work fine because you do that on a regular basis anyway. And then finally, it comes up quite often that people will say, well, can I use my existing traditional security tools in a container deployment? And yeah, you can. You can add that in as additional layers of defense. For example, a traditional, what's called IDS, intrusion detection system, they will look at changes in the file system on your host, and they look for changes that look anomalous, unusual, strange. Now, there is an argument that intrusion detection is actually easier to do in a containerized, orchestrated, cloud-native deployment because your hosts are pretty simple. It's the container images isolate your application code, but the code that's running on the host isn't likely to change all that much, other than in particular places like log file locations. So it actually makes intrusion detection easier and more reliable. And in addition, there are some qualities of running microservices in containers that we can use to make our deployment even more secure. For example, if we've put our containers into microservices, we can start to say, well, this service should only talk to this service and this service, nothing else. So we can restrict the communication between those different services. Even more, we can encrypt the communication between those different services. And if we make it so that containers can only speak to other containers, then it makes life harder for an attacker. If an attacker does manage to compromise one of your containers, one of the first things they'll try to do is use network activity to explore the rest of the deployment. But we limit how much of that network they can actually explore by saying, well, that container should only be able to talk to a restricted number of containers. And this kind of thing makes a lot more sense when we're talking about microservices than it does when we have a big monolithic application. The other thing that we can do is look at what each of those services, what each of those containers is actually doing. If we know what a microservice is supposed to do, and quite often it's not supposed to do very much, it's just got one job. So anything that it tries to do outside of that normal behavior is anomalous. It's a red flag. It's suspicious. It may mean that somebody has compromised that container. And there are ways to do that with commercial tools. Come and talk to the folks on the Aqua booth upstairs to see a commercial tool. But I'm going to show, just with like regular open source tools, the principle behind this kind of thing. And I'm going to do it with Apache web server, which is not exactly what I would call a microservice, but we can use it to demonstrate the principle. So who has heard of shell shock? Okay, not so many of you. Okay, shell shock is a vulnerability that it's in the bash shell. It's been fixed. It's a few years old now, but it was pretty significant vulnerability, and it allowed a lot of web services to be attacked. So hopefully, I have. Is that big enough to see, or shall I make it a bit bigger? Bit bigger? Okay. So I have a container running that has an Apache web server. It's got the shell shock vulnerability in it. Almost certainly, if you pull an Apache version today, it's not going to have this vulnerability, but it's an illustration. And hopefully I can just hit that. Yeah, there we go. So I can get back just some default web page from that Apache server. And Apache also has this thing called CGI bin, some kind of prehistoric way of serving dynamic pages. And I can go to CGI bin, and there's a page here. You can't really tell, but this has been dynamically created. Okay, so I've told you that. Let's show that that has been dynamically created. So I am going to run another container. It's sharing the process ID namespace of my shellshock container. And I'm going to use this to run something called strace on that Apache web server. Okay. So from my tracer container, I can see those Apache processes. And the ones I'm interested in are these HTTPD, the web server daemon processes. And I'm going to look at what's going on in those and any child processes. So they are processes 6 and 7. And I'm actually looking for, it's a system call called execve. Don't worry too much about that if you haven't heard of it. But what that tells us is when we execute another executable, it's done via this execve call. So anytime we run another executable, we'll see it through this trace. So if I hit that same web page again with, well, let's look at the normal web page. Nothing happened. If I hit the dynamically generated web page, we can see a trace that said, yeah, we executed something called hello CGI. So that's normal behavior. That's what I'm expecting. I'm expecting people to come to my website, hit that page, it gets dynamically generated, and we expect to see this kind of behavior. So now let's use the vulnerability. And I do this by sending in a header, user agent header. And I think it goes something like this. And then I can run any script of my choice. And I'm going to write to a file called, I think it goes here. Okay. Oh, I forgot to run actually env. Okay. So what I'm going to do is I'm going to run a shell which is going to run env, which gets my environment, and I'm writing it into a file. And that isn't something that people would normally do. And when I do it, we can see, well, we ran the hello executable again. That's normal. But we also ran a shell, bin bash, and we ran env, bin env. There's no really good reason why that should be allowed. And now that I've done that, as an attacker, I've created that attack, and that's actually created a web page for me that shows me what the environment is for that running process. That could be useful to me as an attacker. I could have run anything. I didn't just have to be env. I could have run anything I liked. So the point is, your code should only do a certain set of activities. And if you can restrict what those activities are, you can be more secure. If we have a way of preventing something like env from being run, that would be pretty powerful. So come and have a chat with Aqua upstairs if you want to see how we do that. Okay, so Cloud Native actually is giving us several security advantages. When we decompose our software into microservices, we can also decompose the security problem. And around each of those microservices, we can do things like add the network protection that we talked about, limit the executions that are allowed inside each of those microservices. And we can only do that because we've broken the software down like that. We can use continuous integration and continuous deployment to make it fast to replace images, to essentially do the equivalent of patching, but do it automatically, get our updated containers with security fixes deployed as fast as possible. And another advantage that we have is things like this event today. The community, I mean, this happens a lot in software communities in general, but I think one of the things that we've seen through things like the open sourcing of Kubernetes and lots of cloud native tooling is that there are a lot of events where people will come and share their best practices. There are a lot of opportunities to talk to each other about what you found to work. And everybody is learning, everybody is improving how these processes work, and we're all improving how security works. So we can all learn from each other at events like this. And there is room for improvement. That survey from last year, a lot of people agreed that there was more that they could do within their organizations to improve security. And there's probably more that you can all do to improve security in your organizations too. Looking at things like vulnerability scanning as a really good example. A couple of quotes from a chap called Doug Carhill at the Enterprise Strategy Group. Containers require collaboration between security and DevOps teams. We no longer have security people as a sort of separate, isolated team who never talk to developers. We're all working on that same CI/CD pipeline, so it's a good idea to collaborate. And this quote I quite like because you can interpret it in two ways. So organizations should be embedding security early into the process. That could be on a human level, having security teams embedded into the discussion about DevOps early on. And it can also be sort of tooling-wise, embedding security tools like vulnerability scanning early into the CI/CD pipeline. So we talk about continuous integration, we talk about continuous deployment. Let's also talk about continuous security. I want to leave you with this URL, which is for a tool called Microscanner. So how many of you, put your hands up again if you're using containers? Right? Leave your hands up if you are vulnerability scanning. Right, okay. So it would be a very good idea for you to do vulnerability scanning. This is free to use, so I would definitely recommend investigating this. You've got nothing to lose, and you will be able to identify whether your container images contain any vulnerabilities. I will be speaking again this afternoon showing exactly what a container is. I'm going to be writing one from scratch in a few lines of code. My colleagues and I will be at the Aqua booth, so do come and have a chat about container security. And with that, I hope you have a wonderful day of containers at Container Day. Thank you.